In this lesson, we're going to work on factoring out monomials. So when we factor out monomials, or when we factor out, we have to use the GCF, which is known as the greatest common factor. And remember, like your multiples, or should I say, your factors will have they will have some common factors, but we want the one that's the largest. That's why it's called the greatest common factor. So if we look at the first monomial here, we have 8x squared minus 80x. So one of the best things to do when you start factoring out monomials is to go ahead and list out the factors. You have to list out the factors. So the factors just mean what are the numbers that you multiply together to get that actual number. So if we look at 8, we can list out the factors of 8. So let's list out the factors of 8. So I want to put over here to the side, I'll say 8, and I'll start with 1. 1 times 8 would give me 8. 2 times what would give you 8? 4. 3, no. 4, we already have. 5, 6, 7, 8, and we already have 8. So there are the factors of 8. 1 times 8, 2 times 4. Then you can go ahead and list out the factors of 80. Because remember, we have to find the greatest common factor between the two. So 1 times 80. Then I'm going to go to 2 next. 2 times 40. Now think about 3. Can we multiply any whole number times 3 to get 80? Of course not. So then we go to 4. 4 times 20. How about 5? 5 times 16. What about 6? No. What about 7? No. What about 8? Yes, 8 times 10. So here are the factors, and that is it, because we already have 16, we already have 20. Let me just double check for 12. Is 80 a factor of 12? Is 80 a factor of no? So 12 is not a factor of 80, as I meant to say. So now, when we look at the common factors, of course, the first common factor they have is 1. The next common factor that they have is 2. The next one is 4. And the final one is what? Is 8. So the largest or the greatest common factor is 8. So we're going to use the 8 and we're going to factor it out now. So when I go back to the original monomial, I'm going to say, okay, 8 is our greatest common factor for 8 and 80. Now look at your variables in their exponents. We have x squared and we have x to the first. What is the smallest x to what power? The smallest power that they both have in common. If you look at 80, if you look at 8, it's x squared. Now look at 80. Does 80 have an x squared, or does 80 have an x to the first? 80 has an x to the first, but 8 also has an x to the first, okay, because it's x to the second, so that means it goes from x to the first, x to the second. So we can factor out at least one x between the two. So it will be 8x, and we're going to factor out the 8x. Then we're going to put a parentheses in. And now what times 8x would give you 8x squared? Think about it. If you said x, 8x times x would give you 8x squared, you would be correct. And what times 8x? What times 8x will give you 80x? If you look at the factors over here, what number times 8 would give you 80? Of course, the answer is 10. But don't forget, this is a negative 80, so it's going to be a negative 10 here. So this is our answer. It's factored out now. We have 8x times x minus 10. All right, so what you want to do here, so I can be clear with this, is you want to make sure you find the greatest common factor for the coefficients. That's the number that's in front of the variable. But then with the variable and the exponent, you have to find the smallest exponent that they have in common. So in this case here, we had x squared and we have x. That means that the 8x squared also can be written, well, if we factor it out, it would have just 1x. So let's go to the next one now. We have 9x squared minus 36x. So once again, we can go ahead and list out the factors and see what is the common factors between the two. So take a few seconds to do that. So for 9, if I list out my factors of 9, I'll start off with 1. 1 times 9 is 9. 3 times 3 is 9. Okay, so, and that would be it. Those are the factors that will get you 9. Now let's go to 36. So we have 1 times 36. We have 2 times 18. We have 3 times 12. And actually at this point you can stop, because if you looked at the factors of 9, well, we can't stop because we have to keep going all the way up to 9, right? Because the largest factor is 9 for 9, so we can keep going. So 4 times 9 would give us 36. 5, about 6 times 6 would give us 36. 6 times 6, 7, 8, and then 9 times 9 would give us 36. All right, so, and then we have our 12, or do we have our 12? We don't have our 12, do we? Actually, we should have had 12 right here, where it's 3 times 3. It should be 3 times 12. So we'll put the 3 times 12 here. So 3 times 12 will give you 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Now, what is the largest factor that they have in common? Because they have quite a few in common. So it can only go larger than the smallest factor here, which is 9. So it is the greatest common factor between the two is actually 9. So that means we can factor out a 9 between the 9x squared and the 36x. So we're going to factor out the 9. So 9 is the greatest common factor. So let's factor it out. Now look at the x's. We have x squared and we have x to the first. Can we put 9x here, because 9x would also factor out, make that the smallest exponent that they have in common? Of course we could. So it will be 9x. Put a parentheses now. 9x times what would give you 9x squared? If you said x to the first power, you will be correct. And then 9x times what number would give you a negative 36 or a minus 36 here? Well, look at your factors of 36. Look at it closely. I'm going to just go ahead and point the arrow to it. Boom. That is the factor that will give you 36. So, of course, we're going to put what? X minus 4. And we can go ahead and close parentheses. We don't need to put an x next to that 4, because if you do, when you multiply 9x times it, you're going to get 36x squared. And you don't want 36x squared, you want 36x to the first power. So this is the correct answer for this one. So let's go to the next one now. So these are pretty much the same with just different numbers. So this time I'm not going to take the time to list out the factors, or am I? Shit, we'll go ahead and list out the factors for this one. So the factors of 3 are 1 and, let me change the color here to make sure that we know that we're doing factors. 1 and 3. Remember, 3 is a prime number, so there's only one number that you can multiply 3 by to get 3, and that's 1. So 3 times 1. So we are finished with the factors of 3. So now let's find the factors of 60. So let's start off with 1. 1 times 60. 2 times 30. 3 times, let's see here, we got 3 times 20. 4 times 15. And I'm just listing the factors even though we don't need all of them because we could have stopped at 3, right? 5 times 12. And our final one is 6 times 10. These are the factors. And what is the factor, the largest factor that they have in common? And what did you say? If you said 3, you would be correct. The largest factor that they have in common is 3. So we can factor out the 3 from the monomials here. So let's factor out the 3. I'm going to go ahead and factor out the 3 here. We get 3 as soon as my screen gets cleared. Okay. Now look at the exponents and look at the variables. They both have v's, and one is v to the second and one is v to the first. So we definitely know we can put v to the first here. Put a parentheses. What do we multiply 3 by to get 60? Well, this is going to be a negative. Well, first let's do, what do we multiply 3v by to get 3v squared? Of course, we're going to do v to the first power. And what do we multiply 3 by to get 60? If you said 20, you will be correct. And you won't have to put a v behind it because when you multiply 3v times negative 20, you're going to get a negative 60v, which is what we have in the beginning here. All right, now let's go to what may look a little more complicated because we don't have a coefficient that is greater than 1 here like we had in the other ones. So now we just have the variable and we have the exponent, but the coefficient is 1. The number in front of these variables are 1, but we don't have to find the greatest common factor for 1 because it's going to be 1, right? So now let's see, x to the 4th minus x to the 3rd times y. All right, this is when we get our practice in a little bit more. So look at the x terms. What is the smallest term that they would have in common here? If you said x to the 3rd power, you would be correct. So we would start there and factor out x to the 3rd. They both can be, you can factor out x to the 3rd here. Put a parentheses here now. What do you multiply x to the 3rd by to get x to the 4th? If you said just 1x, you would be correct. Now, we already have x to the 3rd here, so we don't want to multiply another x. So we're not going to put an x here this time, because if we do, what's going to happen? It's going to be either x to the 4th, x to the 5th, and that's not what we have in our original. But we can go ahead and put a y here and close parentheses. And this is the final answer for this one when we factor it out. Okay, let's go to the next. All right, we have nx squared plus 3 times nx times y. So 3 times n times x times y. All right, don't get confused here. Now, let's see what we can factor out. So if we look at our coefficients, we have 1nx to the 2nd and then plus 3nxy. So that means our greatest common factor here is going to have to be a 1. But we're not going to put a 1, okay? Now look at your variables. What do you have in common? They both have n, and they both have at least 1x to the 1st power, okay? So this is what we can factor out. We can factor out the n and the x, okay? So let's do that. So factor out nx. That'll start us off. Okay? All right, put your parentheses here. What do you multiply nx by to get nx to the 2nd power like you already have right here? What do you multiply? Did you say x to the 1st power? Were you thinking that? If you were, you would have it correct. So x to the 1st power plus, now what do we multiply nx by to get 3nxy? All right, so we already have nx here that's factored out. This has already been factored out. So we don't need to put another nx here when we go ahead and when we start to multiply. So of course we're